Hello everybody, welcome to a review in Acharya. On this video we will talk about matrix equation and how to use it to solve the system of linear equation. Pretty much what we have is we will have a system of equation and we solve for it using the matrix equation. Right, so we just need to know how to set it up first, and then we will solve the matrix equation later. Alright, first we need to convert this into the matrix form. To do that, let's look at the problem on the opposite direction. Let's say we have the matrix equation. Now we try to rewrite that as the linear equation, the system of linear equation. So what we do is, this is a 2 by 1 matrix. 2 by 2 times 2 by 1 will give us a 2 by 1 result. So pretty much we just multiply these two matrices. 6 times x plus 3 times y. That will give us the first entry, and 5 times x and 4 times y give us the second entry. That will be equal to the second, the right hand side is unchanged. Now we will just match the first 6x plus 3y equal to -3 and 5x plus 4y equal to 4. What we see is the numbers 6, 3, 5 and 4 match the matrix here, and -3 and 4 match the matrix there, and we just have xy as the matrix of variable. Alright, now we have formed the matrix equation to the system of linear equation. Now we do that in reverse. Alright, so now we have this matrix, this system of linear equation we're going to write as a matrix. First we will write out all the coefficients. That's actually will be -2. Right, so we have -2, 3, 5 and -2. Right, next there are only two variables, x and y. And then we have the numbers on the other side. Right, and that's just that. So first we have the matrix A, the coefficients, the matrix B, the constant on the other side, and then the x, the matrix of variable stacked in a column. Right, so pretty much that. We'll learn how to solve this equation later. Right, let's look at another one here. Right, so this one has 3 variables, so we should have a 3 by 3. Right, we need to rewrite this first. -2x, there's no y, there's no x, 3y, az and 5x, ay, 7z. Just need to write all the coefficients for all the x, all the y and all the z. Right, so we have -2, nothing, we put 0 when there's no constant there, no coefficient there, and 9, 0, 3 and 8, 5 8, and 7. So that's the matrix of coefficients on the x's, on the y's, and on the z's. We have three variables x, y, z. We stack that as a column, and then the constant will be the matrix B on the other side. So this is matrix A, matrix X, and matrix B, and we have the matrix AX times B. Right. So that's how we set it up. And now we go to the second part. How do we solve this matrix equation, and what an advantage of setting up like that. Right. Now let's look at this problem. By the way, let's focus on how do we solve the matrix equation. If you look on the top right hand corner of the screen, for the matrix equation, if we have AX times B, matrix A times matrix X equal to matrix B. If we solve for X, if it is number, we just divide by A. Cannot do that because in matrices there's no division. We can only multiply by the inverse. Once we multiply by the inverse and the matrix give us the identity times X is still X. Bottom line is we're going to have the inverse of matrix A times B. Right. And inverse of a 3 by 3 matrix, we're going to use calculator for that because it will take a lot of time to find the inverse of a 3 by 3 matrix. Right. So first, I put this into the matrix equation form. So the coefficient will be 1 for x, and -1 for y, 3 for z. Onto the second equation, there are 3 for x, no y, 1z, 1x, 4y, 1z, and then the matrix X, we have 3 variables stacking in a column equal to the constant on the other side. So we have matrix A for coefficient, X for variables, and B for constant. Now AX equal to B, so we have X equal to A inverse B. Right. As mentioned before, we need a calculator for this. Let's put a calculator here. Right. So first, we will need to enter the matrix A, the matrix B, and then A inverse B. Right. Second matrix, go to the third tab to input the matrix. Input matrix A, 3 rows, 3 columns, 1, -1, 3, 3, 0, 1, 1, 4, and 1. Right. 1, -1, 3, 3, 0, 1, 1, 4, and 1. Right. So that is matrix A. Once we're done, second mode, back to home screen. Now we go second matrix. Matrix A is here, there already. Now we're going to put in matrix B. So go to edit, go to the second line for matrix B and edit matrix B to 2 and 18. 3 rows. Once we're done second mode, now back to home screen. Right, now we just need to do A inverse times B. So we need the matrix A first. Under names, that's where we'll recall it. The first line for matrix A inverse, and then times also on the first tab to recall the matrix B on the second line. Enter, and we have 0, 4, and 2. Since the matrix X is X, Y, and Z, X is 0, Y is 4, and Z is 2. So we have that solution. Right. Let's look at another problem. First, let's put in the matrix form. First, 4, -1, 3, 1, 4, 6, 5, 3, and 9. That is the matrix of coefficients. Now the variable X, Y, Z, and then on the other side the constant 12, -32, and 20. Right, so this is matrix A, X, and then this B. AX is equal to B, so X is equal to A inverse times B. Right. Again, 3 by 3 matrix will take a lot of time to find the inverse, and we have to use a calculator. Right, so matrix A, second matrix. Now we're going to input into matrix A again. There's something in there already, but don't worry, we just enter this number on the top of the old numbers. Right, 3 by 3, right, 4, -1, and 3. Just a little note, if we need to use negative, that is the negative, not subtract. 4, -1, 3, 1, 4, 6, 5, 3, 9. That is matrix A, so quick. And then go to where we input the matrix B. Matrix B, 3 rows, 1 column, 12, -32, and 20. Sorry, 3 by 1. 1. Right, sorry. 12, -32, and 20. Second mode, back to home screen, and then we do A inverse times B. Second matrix A inverse is that button. Second matrix again B. So A inverse times B, and we have, oops, what it says is that the matrix has no inverse. So let's do that again. I have to click this. If we just do the inverse of the matrix A, and there's no inverse, so we write A inverse does not exist or is undefined. A inverse does not exist. That does not mean that we have no solution. In fact, if A inverse does not exist, we have two possibilities. Either we have no solution, which is one of the possibility, and another option is, another possibility is infinitely many solutions. Right, because the A inverse does not exist, we have either one of these two cases. Unfortunately, if we use the matrix equation, that as far we go, we won't be able to tell if it is no solution or infinitely many solutions. We have to use different methods to determine that. But if the inverse exists, there should be a solution. And we just use the calculator because, once again, 3 by 3 is too complicated. It takes too much time to do, I should say it. I hope you find this video helpful. Thanks for watching.